Okay, welcome back for one more example of how to implement a regression. This time we're going to be doing it in R. So I've got our R Studio interface pulled up, and just like always, let's go ahead and make a new file, an R script, so we have a little space to work. Now, thus far, for reading in datasets, I've been having you use that read.csv and finding some file within your computer or within the cloud directory we're using to read in. Now, I've kind of not told you everything. Some of the datasets we've been using are kind of default R datasets that are meant for practicing and learning how to work with data, like the CARS dataset or the IRIS dataset. And you actually don't have to read those in because they're actually come pre-built into R. And so there's actually a dataset called CARS. And so without reading anything in, if I head this CARS dataset and go ahead and execute it, we have that speed versus stopping distance dataset without ever having to read it in. And so any other dataset you were working with, you'd have to use read CSV to bring it in like we've been doing. And that's why it was important that I showed you how to do that. But for now, just to kind of save us time in the future, when we play with some of these pre-built R datasets, I'm not going to worry about reading in the CSV when it's unnecessary. So what we want to do is do the same regression analysis we did in Excel of stopping distance versus speed. And so what we first want to do is show you a really basic way to make a linear model to get all of our statistics, which is basically the regression analysis we did in R. And then we will plot it using some of the kind of scatterplot stuff we did last time. And so there's a couple different ways that we can get a linear model, which is a fancy way of saying a linear regression. We can use the function LM for linear model, which is basically, again, linear regression, which is what we've been talking about. It's just a fancier way of saying it. And we could compare distance as the response variable to the predictor speed using the dataset CARS. And so if we go ahead and execute this, we're going to end up getting what the intercept and the slope of the line are right down here. But we can actually get a lot more out of this linear model. So let's go ahead and save this and call this, we'll call this car_regression. Actually, let's just call it carreg to make it easier. So now we're going to execute it again. Because we included those arrows, it's going to save it as that variable carreg. Now, we could do this in a different way too. If you don't like this format, remember there's plenty of ways to do things. We could instead do linear model of cars with the variable distance versus cars variable speed instead of having to add in this data equals cars. These are the exact same thing. It's all personal preference. So pick whichever one you want. But the end result is the same. Our variable carreg now holds that linear model. Now, if we want to get some of our stats, we can actually use the function summary and look at carreg. And now we can see all the stuff that we used in Excel, or that we got out of the Excel analysis down here. And so we can see our coefficients. So again, our intercept, that -17, the coefficient for the x or predictor variable of speed, that's 3.9 and some change. We can see those p-values for each of them. Those are pretty much exactly the same as what we saw in Excel. And then the only thing that's different in placement is right down here is where our actual p-value of the entire regression analysis is, that kind of really important one right here. And it's right after where we get our R-squared values, that 0.65 or 65% of the variation in stopping distance is explained by speed of the car. And so this is an important value here, the p-value of the whole thing. The R-squared value is important, and then depending on what you're interested in looking at, the p-values for the individual coefficients of y-intercept and the slope of the line, or the coefficient that goes with x in the line formula. Okay, so that's kind of the last thing we did in the Excel part. Now let's talk about how to graph this. We can do a really, really simple graph if we want to. Remember, we didn't use ggplot the first scatterplot we did. We did a very simple scatterplot. And so we could do distance versus speed data equals cars, and we could plot that. And now you can see we've got that really basic plot there. We haven't colored anything funny. Maybe we don't need to. And now we can actually take the linear model that we made here, that car regression line. What it is, remember, if we were to execute this car regression, it actually just gives us a line formula. It gives us the intercept and the slope. So we can actually add that line using AB line. It'd be nicer if it was AD line so you can remember add line, but unfortunately that's not what it stands for. And we could add an AB line using car regression and execute this. And now we've gone ahead and added that line right there for us. So now we've got exactly what we had when we were doing Excel. Now you might have guessed what's coming up. We're going to make a slightly fancier plot just to kind of keep things similar to what we've been doing. So we're going to use library ggplot2. We're going to load that in. So now we can use the ggplot function. Let's say it's been a while since you did the first part. Let's remember what we need to do. We want to make a scatterplot, right? And fit a line to it. So let's go back to our cheat sheet. We've already loaded in ggplot. We need to go ahead and add in this kind of, remember that initial piece of information. We don't need to add in that optional fill information. All we need to do is tell it what our data set's called. It's called cars. Our x variable is going to be speed. And our y variable is going to be distance. Okay, so now if we were to execute this, we're going to get an empty plot, but it's got our x and y variables in there properly. So now we want to go, okay, we want to make a scatter plot. So we're going to add another line to this, we'll add a plus there, and let's go back to our cheat sheet. Let's go, all right, how do we make a scatter plot? Right here, stats summary, that geom point, we can go ahead and just paste this whole line in, and we can keep the pieces we want and get rid of the pieces we don't. We don't have like different species or anything like that, so we don't really need to think about coloring the points differently. So we can just go ahead and get rid of that whole aesthetic feature and stick with just geom point. So let's execute this whole thing. And now we've got a basic scatter plot again of those same data. But we can continue to add more and more useful things. We want to add that line in, right? So let's add a linear model or linear regression line. How to fit a linear regression line right here. We can go ahead and copy this whole line and paste it in. Now, what this is doing is it's going to add a line using a linear model, which is basically the same thing we did here with those data. So rather than having to have done all this car regression piece ahead of time, it will actually just calculate that function linear model on your x and y variable and plug it in for you. So this is where R starts to get a little more flexible and time saving. So if we execute this, we should get a red line because I've told it to be red. There's our red line. We could even make it sea green if you wanted. Let's see what sea green looks like. Looks very nice. You'll also notice that we've got our kind of confidence interval stuck in here. This is basically kind of the wiggle room of where that line might actually be that our data support. So we know that this line lies somewhere within this kind of dark gray area, but we're not really confident on its exact placement within there. Okay, so now we can kind of just clean this up, add a few more pieces of pertinent information. We can add all of our labels and all that, which you can probably figure out how to do using kind of this X label, Y label, title that we've kind of been playing with before. Make sure we add pluses in between each of them. And I like to, again, kind of add spaces just so you can tell that it's indented. It's all part of the same thing. And we could add our X label and call it speed, Y label, distance, maybe parenthesis stopping. And then we could say stopping distance versus speed. Now let's look at it. Okay, we're just about where we want to be with this. There's one thing that we're missing on this that we had on the Excel thing that sometimes is nice to add, and that's the information on the formula of the line. Sure, we could go back and summarize our car regression and get our slope and intercept, but that's kind of messy. So what we can do instead is actually add it in by hand. And so what we're going to do is use this adding a regression equation in R squared kind of by hand. There's this kind of flexible ability to add text wherever we want within a ggplot graph. So this function geomText will add text that says whatever we want, wherever we want. So we can basically add a label anywhere in the graph. And so here I'm going to say that I want the label to read y equals 3.932x minus 17.58. So again, that slope of the line, where it's the coefficient for speed, or x, minus or added to the intercept, depending on whether it's positive or negative. Then I also tacked on what our r² value was, which we got down here. And then you have to decide what color you want the text to be and where you want the text to be. So I kind of looked at my graph and I said, oh, I kind of want it somewhere up here. So maybe somewhere where x equals 7 and y equals 80. So somewhere around here. And so here I put x equals 7, y equals 80 for where I want to place it. Now let's go ahead, hit enter. And now we've got the whole thing. Oh, it looks like it's coming a little bit off of the actual graph. So what we could do is maybe we could change this to x equals, let's say 15. And these are the kind of things you can play with. You can change the font. You can do whatever you really want. It's very powerful. You can kind of nerd out on this stuff for a long time. But rather than kind of take up all your time thinking about how to do this, I think I'll just leave you with this. Hopefully, if I were to give you a slightly different data set, you could use this cheat sheet to make a plot and fit a line to it, and then make a graph. It's really just kind of mixing and matching different pieces of a recipe.